Adding and subtracting monomials. So here we're looking at combining through addition or subtraction two monomials. And in order to do that, all we're really doing is combining like terms. So remember, like terms are the same variable or the same variable with the same exponent power. So for example 1, we want to take 3x squared plus 5x squared. And so both of our terms have an x squared. So all we're going to do is add the coefficients. So 3 plus 5 is 8, and then we tack on the exponent and the variable. So we get 8x squared. In example 2, we notice that we have the same combination of variables, x cubed y and x cubed y. So we have 4x cubed y minus x cubed y. So here we're just going to subtract the coefficients. So 4 minus 1 is 3 x cubed y. We're doing the same thing in the next two examples. So for the first one, we've got 6x to the fourth plus 11x to the fourth. We have the same variables and exponent combination, so we add the coefficients. And in this case, we get 17x to the fourth. In example 4, same idea. We've got 2x squared y to the fourth minus 7x squared y to the fourth. We have the same combination of variables, which means we have like terms. So we're going to subtract the coefficients. So 2 minus 7 is negative 5, and then we just tack on the variables and the exponents. So negative 5x squared y to the fourth. Here we have polynomials being added together. So we have a binomial plus a binomial, or a trinomial plus a trinomial. The same thing occurs here. You're going to combine like terms. So you're looking for variables that have the same exponent power and the same variables themselves, and you're going to add those coefficients together. So in example 1, we've got 5r cubed plus 8 plus 6r cubed plus 3. These parentheses in this problem aren't really that important because it's all addition, so we don't really need to keep track of them, so we can kind of get rid of them if it makes it easier to look at. So in this problem, we have like terms with the 5r cubed and the 6r cubed. So we take 5 plus 6, which is 11r cubed. Then we have like terms for the 8 and the 3, and we add those together and we get 11. So our final answer here is 11r cubed plus 11. In the next example, we have 3x cubed plus 4x squared minus 3 plus negative 9x cubed plus 5x minus 4. And once again, we're just going to combine like terms. So we've got 3x cubed and a negative 9x cubed. So we're going to add or subtract the coefficients in this case. So 3 plus negative 9 is negative 6. So we've got negative 6x cubed. Then we've got 4x squared. There's not another x squared, so we go 4x squared. Then we've got 5x. There's no other x term, so we just tack on the 5x. And then last but not least, we've got negative 3 and negative 4, which become negative 7. So our final answer becomes negative 6x cubed plus 4x squared plus 5x minus 7. So the entire process is just us combining like terms. Example 3, same idea. Continue combining like terms. We've got negative 7.1x squared minus 180x plus 5,800 plus 21x squared minus 140x plus 1900. So we've got like terms in the x squared and the x squared. So we've got negative 7.1x squared and 21x squared, which gives us 13.9 x squared. Then we've got negative 180x and negative 140x, which gives us a negative 320x. And then last but not least, we've got 5,800 and 1,900, which in this case is going to give us 7,700. And so this is our final answer. We get the trinomial 13.9x squared minus 320x plus 7,700. go ahead and try this one on your own, pause the video, and then when you're ready to check your answer, unpause the video. So if you did this one correctly, you should get negative 12x cubed minus 92x squared plus 227x plus 6022. This time we're going to look at finding the difference between two polynomials, or subtracting. In these problems, the parentheses do matter for the second set, or the second polynomial. As you can see in the first example, we've got x squared minus 5 minus the binomial 5x squared plus 12. We can't just get rid of the parentheses here. We actually have to distribute this subtraction symbol throughout, or this negative throughout. So that changes the problem to x squared minus 5x, or x squared minus 5, sorry, minus 5x squared minus 12. Now we're going to combine like terms. We take our x squared terms, so 1x squared and negative 5x squared become negative 4x squared, and then negative 5 and negative 12 become negative 17. And so this becomes our final answer. So before you can combine like terms in the subtraction problems like this, you've got to distribute the negative throughout the second polynomial. So in example 2, we've got 4x cubed minus x squared plus 9 minus the quantity 2x squared plus 3x minus 12. So the first thing we want to do is distribute the negative. So we get 4x cubed minus x squared plus 9 minus 2x squared minus 3x plus 12. So now we're going to go about combining like terms. We've only got one x cubed term, so we keep 4x cubed the way it is. We've got negative x squared and negative 2x squared, which become negative 3x squared. We've got one x term, so we've got negative 3x, and then we're going to add positive 9 and positive 12 to get positive 21. So when we're all done here, we get the polynomial 4x cubed minus 3x squared minus 3x plus 21. Example 3, same thing. We'll start by distributing this throughout. So negative 7x cubed plus 5x squared plus 12. All right, so we're going to combine like terms. 1x cubed and negative 7x cubed become negative 6x cubed. Negative 3x squared, positive 5x squared become positive 2x squared. And then we've got plus 5x and then plus 12. Same thing here, distribute the negative throughout. You have negative 4m cubed minus m plus 9 minus 4m squared minus m plus 12. We'll combine like terms. So we have only one m cubed term, so 4m cubed. We've got only one m squared term, so 4m squared. We've got negative m and negative m, which becomes negative 2m. And then 9 and 12 become 21. So we end up with the polynomial negative 4m cubed plus 4m squared minus 2m plus 21. Go ahead and pause the video, try the wrap up, and when you're ready, check your answers to see if you got them right.